Okay, so tonight we actually combined our meetup with the Cloud Foundry meetup. So a few of you who are here from Cloud Foundry, this is the second time we did this. We did this in December for our little Christmas party thing. We did that over at Palo Alto at our other facility. And so Dave Nielsen and I also used to work together a million years ago. It's a very small industry. And Dave combined forces now because there's a lot of synergy between what the Cloud Foundry meetup does, what we do, and what Adrian's going to talk about. So a lot of you are here tonight from the Cloud Foundry meetup, and we thank you. And Dave couldn't be here tonight, so I have an announcement that he asked me to say. So the next Cloud Foundry meetup is going to be in San Francisco on February 25th, and it's again using Docker with Cloud Foundry, kind of a popular topic. So it's at Elation, which is South of Market in San Francisco, and it's February 25th. So if you're interested, their meetup site is very similar to ours because they were the first. So it's meetup.com/cloudfoundry, and you get to the Bay Area Cloud Foundry one, and you'll see that Dave has posted that on there. And we'll probably combine our meetups more in the future because it's useful to everybody. Another meetup that's coming up that I wanted to announce, that I was asked to announce, the East Bay.
Oh, that's
so many notes this time. Oh my gosh. There is a new OpenStack meetup group, and it's in the East Bay. So on March 10th, they're going to have their first meetup, and it's on, guess, OpenStack and Containers. I was like, really, guys? Really? Because anyway, so that's their first. It's on March 10th, and you can go to it's called East Bay OpenStack Meetup. So if you go to meetup.com, the other one, then you can find that one. So I told guys I would tell you about that. I don't know how many of you are going to get over there in traffic, 5, 6, or whatever. But if you are already there, like if you work from home and you live there, then that might be a good meetup for you. Also, the Linux Foundation asked me to mention to you guys, they have an online self-paced course on OpenStack Administration Fundamentals, and they want to offer you guys all a 15% discount on that course. And I will post the link to that, plus the code to get that discount in tonight's meetup thing. I'll just go and put a thing there. And so there is that. There is also a free webinar from the Linux Foundation. This is going to happen February 25th at 11 a.m. Tim Sarovitz will talk on all things OpenStack, what problems it solved. It actually cracks me up. His abstract actually said, why OpenStack is worth the effort. That was in his abstract. So that's a free webinar on February 25th, and from the Linux Foundation. And I promised them I would tell you about that. So I will put the links in the meetup site as soon as I finish all of this babbling. And then, oh my gosh, I'm not done. So OpenStack Summit coming up, yay! So the call for papers went out and the voting was closed yesterday. I'm sure you all voted for me, right? And Sean. Because after my big rant last time, you know you went and voted, right? Because you don't want to hear that thing again, because I was very not happy last time these voting things happened when we voted for things. You missed it, Sean, in the rant. But we won't do it again. But anyway, the voting's closed, but for those of you that did submit papers, you will get your notification, they say by the first week in March, so that you will still have time to sign up for the early bird pricing, which ends March 12th if you still want to get that and for whatever reason your paper didn't get accepted and you have to pay for your conference. But anyway, hope to see you all in Austin. It's going to be a really, really, really good conference this year, and I'll tell you more about it in the upcoming months as we get closer. And the other OpenStack Foundation thing that I said I would mention, the Women of OpenStack mentoring program is really looking for mentors. So this is different than the Women of OpenStack scholarship program that I started here that I've been telling you guys about for a couple of years. This is with the OpenStack Foundation, something that they are doing community-wide, and they are very much looking for mentors. So if you are willing to mentor, please, you can contact me and I will send you an email of how to get involved with the person from the foundation that's driving that. And it would be a great thing to do for everybody involved. Trust me, the mentors get more out of it than the mentees, and it's awesome. And then the last meetup that I will tell you about is our developer community relations meetup that we started. We did the first one last month, and it was a really big success. We had developers from Engineered and Netflix and all kinds of cool companies, which was awesome. Twitter, we had someone from Twitter. And so we have our next meeting is going to be February 22nd. And we have great developers on the panel again this time. We have Jono Bacon from GitHub, and we have Mano Marks from Docker, and Tamio from New Relics, and Couchbase and Keen, and great companies on the panel. So please join us in San Francisco. It's also south of Market. It's at Heavy Bit, and it's February 22nd. And you can find it on the meetup sites if you look for the developer community meetup in San Francisco. Or if you can't find it, ping me, and I will send you the link. So it's a really fun meetup. We just started it. This is our second one, and it's going to be awesome. So are there any? Who here works at HP? Raise your hand. Only 2 people? 3 people? Really? Are any of you guys developers? And which team? Okay, and wait, who else raised their hand? Oh, hi, I know you. And then who else from back there? From HP? You're from HP, okay. And which team? Which one? Oh, okay. Oh, cool. Right on. We had a meetup with you guys. Amit presented a couple of months ago. It's awesome. Okay. So, like I said, my new role is focused on developers. So I'm going to be your guys' best friend. Not that I wasn't already your best friend, right? But I'll be your next best friend going forward. However that works. Okay. Just I'll be coming and talking to you guys. Okay. So the next meetup, as I mentioned, might be at Walmart. Brendan, hey, how you doing, hon? Good to see you. Yes, come and steal some pizza.
Hi everyone, I'm Brendan.
That's Brendan Shepherd. She's fabulous.
No, you're fabulous.
Oh, she's sweet.
Just saying.
Oh, wow. Okay. Awesome. Thank you. You can join our meetup anytime and say nice things. Okay, so like I said, the next meetup is probably going to be at Walmart. Give Sean a day or 2 to sort that out, and then we'll post it on the site. We also have a Keystone team that wants to come back and present, and so that'll be one of the upcoming meetups. And also, high availability for OpenStack is probably going to show up on the schedule over the next month and a half. So those are some of the things we have lined up for you. And the guys from Stratoscale wanted to come and present. So, okay, Sean, would you like to say stuff?
Just add one thing. Hi, I'm Sean.
That's Sean.
How y'all doing? So one thing to add for the Austin Summit, for about, I think it's probably going to be the 5th or 6th time, there's training on how to be an OpenStack developer. It's called Upstream Training. It happens the weekend before the summit. So if you are a new to OpenStack and you want to learn how to get involved with the project, that's an excellent thing to do. You can find it off of the front of the OpenStack site. You can also do a search on Upstream Training. I think it's still free. So if you wanted to, you can just show up and go to that. So it's
Without learning something.
2 days. Yeah, you could.
Okay.
Good. So just wanted to remind everyone.
Yeah, and actually that's a good point. Austin is all of a sudden very popular for conferences, and we're doing OSCON there this year too, the other big open source conference. And the weekend before OSCON is the Community Leadership Summit, also free. Jonah Bacon's gonna run that one again. And so just like come and hang out in Austin for all of April and May, and you'll have a lot of cool folks in town. Okay, is everything working? Oh no. Okay, so just hang tight. We'll get there soon enough. So I didn't really introduce Adrian other than saying he's the PTL of Project Magnum. He's also at Rackspace and has been a member of the OpenStack community for quite some time. And you may have seen him since day one, right? Exactly. Yeah, so he's one of the people that can kind of really legitimately claim to have brought us this beast from the beginning. And as you see the NASA sticker on the back of his computer, he doesn't live here, so this has got to be exciting to him to be across the street from NASA where OpenStack was actually invented, which is cool. It's got to be exciting for you guys too if this is your first time here and you didn't realize that if we hold up all the blinds and let you see it. That is where OpenStack was invented. So pretty cool. Little trivia space and pretty awesome to be able to have this space and to host all these you guys because we've had much smaller spaces in the past. So this is really cool. So it's a treat to have Adrian here, and he speaks at conferences all over the world, and maybe you've seen him speak before, and he always entertains us. And it looks like he might actually have some slides to back him up on at least one of the screens. That one often doesn't work, so yeah. I'm surprised this microphone has worked this long. And we have a microphone stand, so I'm not gonna have to run around like a maniac during the question and answer period. I'm actually going to place the microphone on that stand, and I'm going to trust you guys that you can ask questions in the form of questions and not speeches. So, if you can come up and ask a question, because otherwise I have to stand next to you and kind of like do that on your foot. But I'm gonna trust you. And so I'm gonna put the microphone there. And then you're going to be able to ask Adrian questions. Now, if you feel the need to interrupt Adrian during his presentation and ask a question, then I may grab the microphone and run over to you. And the only reason is because of the Google Hangout. They really need to hear what your question is, and unless Adrian can remember to repeat your question every single time, then we need your questions on the microphone, or the rest of the planet gets very sad, and we hear about it. So I will ask you to either wait till the microphone gets to you to ask your question, or to actually just walk up to the microphone and ask your question. And you're okay to get interrupted with questions, or you want to call him?
Whatever.
He's easy going. He's not like one of those high maintenance stackers. We've had them. We know who they are. Yes. Are you going to make your slides available to folks?
Sure.
Sure. Yeah, we can, unfortunately, because Meetup.com is super kludgy technology, I can't actually post them, but I can put them on the SlideShare, or you can put them on Foundation. Yeah, put them on your SlideShare or Foundation SlideShare, and then just post the link in the Awesome. Unfortunately, yes. So, unfortunately, all the things I just said, including that comment about mascara, is probably recorded. I don't know, Rick, have you started the recording? Yeah, it is. It is, it's already there. If you go to the Meetup site, the Google Hangout, actually, I think you post another link afterwards, but it's right now, the link is on the Meetup site, and we are live. Hello, world. Hi. Hope everybody's having a good time out there. Not freezing if you're in the East Coast. Not too tired if you're on the other side of the planet. What is the problem? Are we ready?
We're ready.
Rick, are we ready?
Sorry for not getting the slides. I see a slide on my computer.
Wow. We started Meetups late, but I think this is a record. No, honestly, but I shouldn't have much to say. Everybody emailed me this week saying, you have to mention this stuff. Sorry, give us one more second, because it's really useful. It's helpful for the recording and for the people in the rest of the world. They really do watch our recordings.
Since you started the Hangout, if Adrian emails you his slides, maybe you'll have better luck.
Isn't this use your computer? It usually works fine from the presenter computers. Is it still not working?
No, it's still working.
Okay, well, if you want to do that, we can do that.
Can you email the slides, and then you can just start working and
Start
doing the presentation, and then that way you can start presenting, and he'll work on it in the background.
honestly, this has actually worked well. Everything, at least one thing breaks each year. Last time it was the microphones, which was really ridiculous. And this time it was the slides, and it's all in that.
Oh, I know what it is. Let's find, why don't we see your slides? So this would be Keystone? No, Keystone. So, what's the, I'm sorry, I can't think of the app.
Yeah.
We can't do entire screen?
Just try, yeah, go ahead, try the entire screen. Okay. Oops, Keynote is what I was trying to think of. Sorry.
I do. All right, so. Okay, yay, we got it working. Sorry about that, folks. Okay, so did you put it on the mic? Not with you at all. Did you turn it on? And, okay, Elena? Yeah.
Okay, sorry.
Oh, did you go to full screen mode? Can we not do full screen mode? No. Let me just try something.
This presentation is embedded video. It won't work this on the screen.
Okay. All right, we're gonna probably have to give up on.
Projecting on the hangout. Yeah, let's project. Yeah. Yeah. We'll just post the slides later. Can you say something and test it? Is it too far away?
Is that better?
Can you?
Is that better? More, Adrian? More?
And then just put the link on Meetup. Great, awesome. Yeah, thank you. Wow, you guys are great for your workarounds. Oh my gosh, I think you're turning the wrong mic up. Okay, yours is up too? Can you guys hear Adrian?
Can you hear me? Yeah? All right.
Okay. Well, then I'm getting off the stage. Go, Adrian.
All right. So, I'm going to tell you about 4 things. I'm going to tell you about the history and overview of OpenStack. I'm going to tell you about Karina, which is a use case for OpenStack Magnum. And I'm going to talk about Magnum in some depth. And when I'm done with that, I'm going to talk a little bit about the different container orchestration engines that Magnum enables. Now, we have some special guests in the audience who I wanted to identify. We're here this week to work on the Magnum mid-cycle. So OpenStack is on a 6-month development cycle, and halfway through, each project can get their key developers together and work through the issues that are kind of halfway done for the release and figure out how we're going to get everything finished. So that's what we do about every 6 months. We're having that right now. So we have almost the entire core development team for Magnum is here tonight. Why don't you stand? So these are the creators of the software. So I've never been able to make a Magnum presentation with this many represented in the same room at the same time because we're such a globally distributed team. So I feel privileged to be able to show this to you in front of those who are responsible for making it. So in 2010, NASA and Rackspace got together and came up with this idea to create a new software that would be for creating open source based clouds. Since then, 5 years have gone by. In June of this year, we celebrated the 5th birthday for OpenStack, June this past year, 2015. Since then, 27,000 members have joined the OpenStack Foundation, represented from 167 different countries, and over 523 different organizations are involved. But this isn't just about software. This is about a market. According to 451 Group, the OpenStack market is growing by a 40% compound annual. And in only 3 years, it's expected that this is going to be a multi-billion-dollar market. OpenStack is a collection of services, the most simple of which are compute, storage, and networking. And we arrange these into this concept of layers. The foundational ones are Nova, Glance, and Keystone. Those are the ones on which you can extend and build additional services. So Magnum is possible because it leverages a lot of other OpenStack services. It uses Heat, which in turn uses Nova. It's integrated with Keystone. It uses Glance. It uses Barbican. It uses Swift. It uses Neutron. And soon it will also be using Ironic. So let me show you what Containers as a Service looks like when it's in production. Do you remember 7th grade when you were in physical science class and your teacher was like, the difference between a solid and a liquid and a gas? Well, my favorite was always liquid. And the reason that was always my favorite is because it was like the most undefined of the phases of matter. And I think about liquids a lot. And I think that software is actually a liquid. And when you think about the properties of a liquid, they take the shape of their container. They have intermolecular attraction. And their matter, their molecules are not in a fixed position. They're malleable. And in addition, if you think about water as an example of a liquid, it has certain properties. It has cohesion, meaning it sticks to itself. And it has adhesion, meaning it can stick to other things, just like software does. So imagine that water is software, and that glass is its container, and it's taking the shape of that container. And I want to make, I'm ambitious, so I want to use more software. How do I get more software to run? Well, I need a bigger container. And how do you get a bigger container if liquid is actually fixed volume? How do you do that? Well, you need a bigger container. You need bigger hardware. So if that glass is the hardware and the water is the software, in order to run more water, you need more glass, right? So what Rackspace does when they're faced with this challenge is, let's just design a bigger computer. So we got this concept of a barrel eye. This is a project that a colleague of mine, Aaron Sullivan, and team have been working on as an open pursuit in both the open power and open compute communities to make an open source hardware that is giant. In fact, this computer has so many CPUs. This particular one has about 160. If you were to run top, this is what would happen. And way at the bottom would be where your process ID was. So like, that's how many CPUs you can fit into one box. But even if you could fit 160 CPUs or 200 CPUs into a box, at some point there's a limit where you can't fit any more hardware into the box and you need another approach. So I talked about the hardware is your solid. There's another kind of container, another kind of solid that you can think of as an application container. This is what Magnum is intended to offer you. Okay, it's intended to take the best application software and make it available to you. Now, application containers are the most disruptive innovation that has happened in computing since the introduction of the virtual machine about 12 years ago. It changes the way we think about software bundling, distribution, orchestration. It totally changes almost everything about workloads. Now imagine if you had a way to get an effectively infinite amount of compute power, not in minutes, but in seconds. Imagine what would be possible if that you didn't have to pay for that by the hour, but you could pay for it by exactly how much you used. If you just had compute at your fingertips that was that fast. That would be totally transformative. Imagine the things that you could do with that. So Rackspace offers this product called Karina, which is based on OpenStack technology that allows you to do just that. It's available for free today. It's in beta. And it's available at getkarina.com. And this gives you an idea of how you can simplify the world of computing by giving a really streamlined user experience. And containers make this really easy. We've made containers easy in Karina. In fact, if any of you went to the Tokyo OpenStack Summit, you might recognize this guy. This is Jackson. He's my son. He's in this, he's a 10-year-old. And he showed us that you could start a Karina cluster and run containers on it in a matter of seconds. And that you didn't need a PhD. In fact, with only about 10 minutes of training, he was totally commanding the CLI. So let's see what Karina looks like. You click on a button to add a cluster, you give your cluster a name, and you wait about 45 seconds. Let's skip ahead. At that point, your cluster goes active. You click a button to download a zip file that contains the credentials you need in order to interact with the cluster. Save that in a local file, and at this point, we can run a script. So this zip file contains a thing called docker.env. So I source this, and inside, this sets up my command client so that when I run Docker commands, instead of running against my local Docker instance, it runs against Docker that's running in the cloud. So that top right there is running in the Rackspace cloud instead of running on my local machine. Just that easy. Now, Karina is a little bit different than most container services because it runs at bare metal speed. It is not overlaid on top of virtualization. It is using container technology all the way down to the metal. And it offers you a native API experience, meaning that you're not using a proprietary API in order to interact with your containers. You're using the standard container tools. You're using Kubernetes client. You're using Docker client. You're using Docker Compose. All of those things work against these standard APIs rather than using something that is vendor specific or even OpenStack specific. So software is a liquid, and you choose the container. So let's get into Magnum. So OpenStack now has this service called Magnum. And inside Magnum, you can create a new cloud resource called a bay. And inside of a bay, you run another piece of software called a container orchestration engine. We refer to this as a COE. You probably haven't heard that term before because we invented it. Nobody had the concept of running multiples of these at the same time, so nobody needed to talk about this as a category, so there wasn't a term for it. So the Magnum team just dreamed this up. We started calling it COE. So container orchestration engine is a piece of software that lets you organize and run and manage your containers. We give you three choices. We have Docker Swarm, Kubernetes, and Apache Mesos. And of course, this is modular, so others can be added. Now, why would you have these different COEs? Well, you might want to have the native Docker experience side by side with the native Kubernetes experience. And because you can create bays just like any cloud resource, you can create as many of these as you want. Now, OpenStack gives us the ability to run compute not only on virtual machines, but also on bare metal. So where we're going with Magnum is giving you this choice and deciding whether you want to combine virtual machines and containers, or running virtual machines in a pure bare metal environment. In fact, there's yet a third way to do this, which is with nested containers, which sounds insane until you think about it for a bit. So let's look at some stats. Magnum's first release was about a year ago. We just celebrated our first birthday. About 133 different engineers have contributed from 34 different affiliations. There's over 250,000 lines of code there. This is pretty unusual that you would have a diverse set of contributors without one dominating all of the contributions. Normally, open source projects have a leading contributor and a whole bunch of small action happening on the side. And Magnum is quite the opposite. It is very well spread across a number of different sponsors. And the reason why this matters is that when, as an IT decision maker, when you're deciding to base your IT on a fundamental technology like OpenStack, you want to make a selection where if any one of these vendors decides to stop participating for any reason, that you're still going to have a choice, right? That project is still going to live on. Now, Magnum isn't the first project where container capabilities have joined OpenStack. In fact, containers have been in OpenStack for many years. There's a driver for Nova called the libvirt LXC driver. And this essentially allows you to have an instance, a compute instance. Instead of that compute instance being a virtual machine, that compute instance is a container. But there's some problems with this. I'll talk about this in a minute. There's also this another alternate driver called the Nova Docker driver, which works kind of like libvirt LXC, except it has a Docker daemon running on each compute host. So you get Docker containers running instead of virtual machines. And there's also a heat resource for Docker, meaning that you can do an orchestration of cloud resources, and on top of a particular cloud server, you can have containers within the cloud server. All of these things have been there for at least 2 years. But all of them come with this problem that they're not designed for appropriate multi-tenancy. The containers that end up on your compute hosts are not properly isolated from each other from a security perspective. So if you use the libvirt LXC driver, you'll notice in the documentation that it's like not for production, is kind of plastered all over it, and it's for this reason. So when we were thinking about how to get containers into OpenStack, the initial thinking was, hey, this should be plugged into Nova because containers are a way of providing compute. We already have a compute service, that's where this should live. And the more we thought about that, the less sense it made. The more we talked about it, the less this looked like a good idea. Now, what you can't see here is well, it should be a Venn diagram of 2 circles overlapping in the middle. And containers have a different life cycle than virtual machines, and they have a different API from virtual machines. And the things that you do with containers, killing them off, starting them, setting environment variables, binding volumes, attaching terminals to them, starting new processes within them, these are not things that Nova handles. It's kind of totally out of scope for Nova. And things that Nova does might not make any sense for containers. Things like resize and restart and attach volume don't make any sense for containers at all. So there's just very little overlap in the middle where really all you have in common between containers and Nova instances is the start and stop of them. And that's about it. So this really needed to be a new entity. So with all of these different choices for container technology, IT decision makers take a risk in choosing one. Are you going to choose the right one? So if you ask me, Adrian, what container software should I pick? What should I standardize on? If you ask me that right now, I'm going to give you an answer. It's going to be based on what's happening right now. If you asked me that question 6 months ago, it actually would have been a different answer. And if you go back 3 months before that, it would have been a different answer. And maybe 3 months from now, my answer would be different. And things are changing at such a rate that pretty much whatever you pick, you're screwed right now. because things are changing so fast. The way that you mitigate this risk is by choosing a strategy that gives you a pluggability story, gives you some options, so that if what you choose now ends up not being the prevailing technology in the future, you have a migration strategy. You have a way to adjust and follow what the prevailing software is. OpenStack is modular, and in the spirit of modularity, in the same way that we're modular for networks, for compute, for storage, we're also modular for containers. The idea of having containers as a first-class resource in OpenStack is really, really sexy. But what is not sexy is the idea that there needs to be this OpenStack facade on front of really compelling container software underneath. What we found is that people who want to use container tech want to use a particular tool because they like that tool. They don't want another something in between their really cool tool and their container experience. They want it to be connected directly up. And this is why this native API experience is so important. And that's why when we provide these container orchestration engines, we not only provide the OpenStack APIs for managing these things as a bay, which I'll talk about in a moment, but we also provide the ability to connect directly to them. So these are the resources that were in the Magnum API as of the last release. All the different Magnum bays had the idea of a container, a bay, and a node. We've actually since taken node away. So the only thing that all COEs have in common is container and bay. A bay is a resource that is a grouping of Nova instances. So you actually create, in the process of creating a bay, Magnum is going to talk to Heat to do some orchestration. It's going to order up an arrangement of Nova servers on which it's going to overlay your container software and give you the ability to run any multitude of containers on top of whatever number of machines you ordered. The first COE that we supported was Kubernetes. And Kubernetes also had abstractions for pods, services, nodes, containers, and replication controllers, which isn't pictured. We're currently in the process of deciding how to simplify this so that all of the bays in Magnum have exactly the same resources represented. So let's talk about some of the ways that Magnum is different than container software that came before it. First of all, multi-tenancy is designed in OpenStack from the ground up in every single one of its services. Meaning you can have different tenants that are using the same control plane to access isolated data planes. For example, if you start up a Nova VM, two different users both talk to the same API service, but they each get isolated places to run their compute workloads. When you start a bay in Magnum, you end up with this entity called a bay that is similarly isolated, so that different tenants are not sharing the same underlying resources, so that they're properly isolated from both a performance and a security perspective. Second, it has an asynchronous API, meaning when you create for example, a bay resource in Magnum, you're going to get a 201 created response back, and you'll be able to pull the API for status, rather than having it block and wait for that operation to complete. It does not reinvent orchestration. So every single container orchestration engine, funny that orchestration word is in the middle, all have their own idea of how containers should be dealt with. This is not something we wanted to do yet again. So instead, all of our orchestration just leverages the Heat service for the creation of the bay resources. And once you have your COE environment, it manages the containers that run on top of it. And we're also integrated with Keystone for identity, meaning that the same credentials that you use to create resources in your OpenStack cloud, such as Nova VMs, Cinder volumes, etc., is the same set of credentials that you're going to use to create your Magnum bays. So in the most recent release in Liberty, we added a bunch of new stuff. The first was an Apache Mesos bay type. So before that, we had only Kubernetes and Docker Swarm. That bay type features a marathon framework, which allows you to have a REST API to create containers on top of it. We also added what I call the TLS feature. The TLS feature is the way that your native container client software is going to authenticate against their APIs. So when you have a Docker client and it communicates with a Docker service, such as Docker Swarm, that communication is encrypted and verified using a TLS certificate. That's how the authentication works.
Is that dual authentication?
Is it dual authentication?
Both sides of them.
Yes, it is both ways. They both share the same CA. They're both signed by the same CA. So Magnum takes care of the certificate generation, signing, making sure it gets onto the Bay nodes properly, make sure all of the components are configured to use these credentials, and gives the client a way to retrieve them so that you can do things like I showed you with Karina, where you downloaded that zip file and it had the credentials inside of it. Okay, that sort of thing becomes possible. We also added support for external load balancer. The way this works is, let's say, for example, you've got a Kubernetes bay, and you've got a pod that has multiple nodes in it. And as you scale the application layer of that app, you want those application nodes to be mapped in a neutron load balancer. But you don't want to handle manually going into OpenStack and adding stuff to your load balancers. You want that just to happen totally automatically. That's what this integration does. We also added support for Kubernetes multi-master. Now, setting up Kubernetes, has anyone tried to do that? Set up Kubernetes before? Was that an easy process for you? I see a no. Well, setting up multi-master Kubernetes is even more of a no, not an easy thing to do. However, if you have an OpenStack cloud and you've got Magnum running on it, setting up a multi-master Kubernetes takes just a couple of minutes and a couple of clicks, and you're done. So let's talk a little bit about each of the different container orchestration engines and why you might pick one versus another. So first, let's cover Docker Swarm. So Docker Swarm has a concept of a swarm manager. You can think of this as the front-end entity, the API service that you're going to interact with from your client. And then it has some arbitrary number of swarm nodes, which are where the containers actually start. The Docker daemon on each of those swarm nodes makes a connection to a discovery service to register it. So the membership information for the cluster is actually in a distributed service called a discovery service. And once those are registered, then the swarm daemon will be able to distribute work to each one of them. It has a configurable, Docker Swarm has a configurable scheduling strategy and pluggable scheduler, so you can configure how it behaves. You can do things like tagging a particular Docker daemon so that when you run a container, you can cause it to run on a particular node. Let's say, for example, this node on the bottom left has SSD drives in it and the other ones don't. I might label that one with SSD, and when I want to run a container that has SSD performance, I might use an environment variable like -e SSD equals 1. I would pass that through, and it would allow the scheduler to hint to run on that node instead of the others. That sort of thing is possible. The strategy is pluggable. So let's say you've got this and you want to fill a node and then fill another node and then fill another node so that later you can tear them down and have those things disappear, right, in an elastic workload case. That's called bin pack. Or you might use the random strategy where you've got some fixed amount of capacity and you're going to just spray your containers evenly over all of them. And that works in private cloud scenarios where you want to have even utilization of all of the infrastructure that you own. Kubernetes is a bit more sophisticated. Unlike Swarm, which I would describe as a imperative system by design that you can put declarative tools on top of, Kubernetes is a declarative system, meaning the input to this system is a YAML file that describes the end state. You simply explain, this is how I want my cluster to look. You feed that in. All of the intelligence is in the system. It takes care of it for you, and pop, out pops the working cluster the way you asked. It has, again, a central component called the API node. It has on each of the slave nodes this thing called a kubelet. It also has a component called a proxy, which allows for the networking of these together. Most folks that start with containers that are just trying to do things like 3-tier applications, the backends of mobile applications, these sorts of things with relatively popular architecture patterns will fit very nicely into Kubernetes and be very happy with this. If they want to do something more exotic, they may prefer to have more control. They may pick another COE that would be a better fit for that. So let's look at one of those. So Apache Mesos has been around since 2009. It was originally a development from some PhD research students out of UC Berkeley. It has a concept of a master again, except that master is based on a Zookeeper cluster, so it has high availability built in by design. So if you lose any portion of that master entity, it continues to work. It has a concept of frameworks, which are pluggable. By default, Magnum gives you the Marathon framework, but there are other frameworks that work with Mesos. You can use one called Kronos. You can run Hadoop in there. You can actually run Kubernetes as a framework, which is kind of confusing. But the Mesos itself is not container specific. It's really a scheduling and job organization system. And if you're going to use Mesos to run your containers, you would do this if you have a lot of very task or job-oriented workloads. If you're a big data shop, if you've got like extreme number of physical hosts, like in the thousands or tens of thousands of physical hosts, and need something extremely scalable, it really shines at that. So in review, I talked about OpenStack. I explained how Karina is a real-life use case for OpenStack-based container technology. I explained Magnum and a bit about how it works. And I talked about some of the popular, three prevailing container orchestration engines that Magnum supports. If you're looking for work and this sounds like interesting stuff, talk to me. Now I'll take your questions. Right? Hello.
You have to turn it on. Sorry, I turned it on. On the bottom.
At bottom
There's a little thing.
no, other bottom.
Sorry,
There we go.
Now, my question is, how's the networking done when containers are running on different hosts?
So how does multi-host networking work? So that's a great question. In the Kubernetes Bay type, we use an overlay network that's based on Flannel. This essentially produces a VXLAN network overlay. So you've essentially got a virtual network on top of the Neutron network that we create. Now that's not going to be the way it's going to end up long term. We've actually done a lot of work over the last release to put in a container networking model that will allow us to plug in a new component from Neutron called Courier, which is a Docker native driver for Neutron that will allow us to create from the network that's on the bay, you'll be able to interact directly with other neutron ports. So you'll be able to do things like VM to container communication. So you can do things like run your DBAS instance in your OpenStack cloud, or run your own data store on Nova instances, and have your container environment be able to interact with that over the network as well.
Two really good ones. First one is Magnum available in DevStack currently?
Is Magnum available in DevStack? Yes.
Excellent. Where did the name Magnum come from?
Where did the
name Magnum
come from? Magnum came from the Nova PTL at the time. Yeah. Magnum, you can think of, well, I can elaborate on that a little bit. A Magnum is a container for Champagne. So, for Champagne.
So, two questions. First, there is diagram which describes the resource of Magnum 1 or 2 in red. Said that there is no recipe and there is a container. So, relationship between node bay and container is one, which is different in those two. That is in the Magnum, and the next one which is in the Kubernetes. So I want.
You're asking about the difference between these two and why they're different?
Yeah. So what is the service portion of it and pod portion of it comes up here?
Yeah. So Kubernetes has a built-in concept for service discovery. You can think of this as a way to map network access to your container instances, and we have an abstraction today that allows you to represent these in Magnum as well as in Kubernetes, right? So if you create a service resource in Magnum, that will map to a service in Kubernetes.
So Bay is just a collection in the previous Magnum as a bunch of hosts which you collect and try to use.
Right.
But what is this service? Do we discover to service something?
So the word service is very confusing because it's a very overloaded term, and it's unfortunate that the Kubernetes designers selected that name for that purpose. But the reason why it's named service in Magnum is because it's named service in Kubernetes. But it is not a service of Magnum. Does that make sense? It's a service of your application.
So if that is the case, then the question follows that application containers you spoke about in the beginning. So do they represent that, application containers?
I'm sorry, I didn't hear it.
You mentioned something like application containers.
Yes, application containers.
So in the Magnum, the containers which they refer to, they are application containers.
Yes, they are application containers.
What is this container then? Is it a service container? And what is that relation to the service part?
No, it is an app container.
So container is still app container.
Yes.
Then what is the service and pod relation? Like pod, when we say pod, my understanding is that in a pod, example, in OpenFE, open platform, we say a pod is a bunch of 6 servers or 5 servers put together. So what do I understand the pod?
All right.
Pod with respect to service before I get to the container.
How about this? We're taking out service in the next release. This is a discussion that we're having in the mid-cycle right now. One of the reasons we're doing this is because the answer to your question is different depending on what the COE is. And we don't want people to be confused. Instead, if you had a question, I would love the answer to this question to be, if you want to know what a service is, look at the documentation for Kubernetes. But because we've represented it in this way, the answer to this is it depends. Right?
Okay, what would be the solution to get this out and explain something that will be helpful to us?
So instead, what we would offer is the ability to create the bay, and then you use the Kubernetes client to create everything about that pod. So you need to understand how Kubernetes works in order to use Kubernetes, right? You're going to create replication controllers, services, pods, and you're going to define your application in that way. You don't define, when you create an app in Kubernetes, you don't define containers. You define pods, which are groupings of containers. So you've got to understand that if you're choosing the Kubernetes Bay type. Now, if you choose the Swarm Bay type, things are much more simple, right? You've got a Bay that gives you this API that you use to create containers in. It's that simple, right? If you choose Kubernetes, you have all of these other abstractions to conceive.
Okay, so that tells at least the pod is bunch of containers, but service is that discovering that pod?
Service discovery is a feature of the Kubernetes Bay type. It's a feature of Kubernetes.
So that is,
Yeah,
thanks a lot.
you're welcome.
I'm just trying to clear a confusion I have. It seems a lot of these frameworks are in a way trying to manage a cluster, workload, resources, start the container, stop the container, give it resources, all that. In a way, for me, this is all just consuming containers. Can we say that Magnum has an advantage of overseeing or maybe controlling different frameworks, or it's just similar with different features?
So Magnum has this concept. I didn't really talk much about this, or might not even mention this, but as a concept of the Bay is scalable. Okay, so I said a Bay is an arrangement of Nova instances, right? What I didn't say is you can indicate exactly how many that should be, and that can change, right? So you can start with, say, 5, and you can make it 10, and then you can make it 50, right? And you can make it 20 again, and Magnum will actually grow and shrink the capacity that your COE is on, which is different than you would get if you just said, hey, give me some Nova instances, I'm gonna slap Kubernetes on top of that, and I'm just gonna run container. I'm gonna run my containerized applications by describing them with kube files, right? That's a different experience because now you're in charge of manually taking care of what capacity you put that COE on top of. Whereas when you choose Magnum, you allow Magnum the ability to scale out the capacity that your containers are actually going to consume by giving them more Nova instances, right? So yes, from that perspective, we are managing the capacity of your cluster. And then the COE is responsible for managing the distribution of the different components of your application throughout the cluster that you create. Does it make sense? Okay.
Magnum normally issue orders to the underlying structure through Kubernetes and Docker. Is that true?
I'm sorry, can you rephrase it?
Magnum has to go through Kubernetes and Docker to do anything at all.
That's right. You can't. Magnum is totally useless to you unless you select at least one Bay type, right? So you can have a Bay of type Swarm, which means now you've got a Docker API to create Docker containers in. Or you can create a Bay of type Kubernetes, in which case you've got a Kubernetes API, which you can interact with to create Kubernetes apps. Or you can create a Mesos one. Or you can create all of them side by side. I can have 5 Kubernetes bays, I can have 2 Swarm bays, all going at the same time, all on the same cloud.
So
all potentially belonging to different tenants or the same tenant.
My question is, can the Magnum do everything that Docker or Kubernetes can do?
No,
or do you have,
it's not. It's not aiming to duplicate the functionality. It's aiming to enable your access to the native features within each of those.
So then to have a complete configuration, you have to use Docker as well as
Yes,
Kubernetes.
as a consumer of Magnum, actually today you have a choice. You can use the Magnum client to create your Magnum bays, and then you can use the native tool like the Docker client or the Kubernetes client or whatever in order to interact with the COE directly, or you can just use the Magnum client and create containers inside of it. But you shouldn't expect that every single feature that's in every COE is going to be represented by Magnum, because then we have no consistency across bays. And we're also talking about potentially taking that out and making that a modular optional feature so that cloud operators that want to give their end users just an OpenStack client can create containers, or they can only create bays. And when they have bays created, then they use native tools to interact with them. There's a different point of view on what kind of cloud you're going to be operating depending on what your aims are. Public service providers are going to want to give a lot of choice, right? Private enterprises, private cloud operators may not want to offer so much choice. They may want to have a much more constrained environment.
So the choices are you're either an OpenStack environment or you're a pass-through to Docker or something.
Yes, you would be able to choose which of those realities you prefer. Yeah.
So at the previous summit, I attended a session about Murano is an application catalog, and they're mentioning how easy it was to deploy Kubernetes. And you just talked to, are you collaborating with them, or?
Yes, in fact, in Tokyo, there was a conversation between us and the team responsible for Murano. And we talked about there's this confusion within the community of the overlap. There's this narrow area of overlap where Murano can create Kubernetes and so can Magnum. Is that what we want? And we came to an agreement that that's in fact not what we want. When you create a Kubernetes app using Murano as a catalog, what it will do in the future is call Magnum and create a Magnum Kubernetes bay. So there will be no more overlap when that's done, and no more confusion.
That'll be the next release, or?
That's up to Murano to prioritize that work, but yeah, it's the idea is not to have competing interests to pursue the same outcome.
So one more question. If hypervisor is there, that's a container. A VM is there inside that, that's another kind of something running in the. So can you use container orchestration engine as a COE for a hypervisor instead of using what we call VM for container? Is there a possibility?
Like, could you decide not to run Nova?
Example, why I give this question is we use something called cloudlet at the edge for edge orchestration of applications.
Okay.
So I have to decide now I want to use for cloudlet some form of what we call container. So we prefer in the network function virtualization in the telco industry, we say that VM is the most secure thing. Container is not. Okay. But however, if we agree that application containers which you are already developing, they are secure, fine. If not, can we use hypervisor as a container? And your container orchestration engine orchestrates hypervisor, and then on top I can have containers, like I can have a VM as my container. Is that possible?
Yeah. So you're talking about security isolation as a topic, and using virtual machines or containers is the right fit, depending on what the desired isolation level is. Did I understand the nature of the question?
Mm-hmm.
Okay, so when you create a bay, you can decide whether that bay is going to be, today you can decide to provision this onto Nova instances, right? It supports virtual machines. So your bay is actually composed of virtual machines, which is what's going to give you the security isolation versus other tenants that are running on the cloud, their workloads, right? Within those virtual machines, we create containers. The COE actually creates the containers, all right? So you've got the security isolation of virtual machines in this case, and you've got the kind of application management experience of containers. So you get the benefits of both, but this comes at a performance penalty, right? Because you're not getting bare metal performance from those containers. So another arrangement would be, instead of us giving you a bay made up of virtual machines, instead give you a bay made up of bare metal machines, in which case your containers are getting put onto bare metal in groupings that are reserved just for you. This gets the benefit of you get much better performance from the workload, because it's not going through any virtualization layer. The drawback of this is that you've got to buy your capacity or consume your capacity from the cloud in units of entire machines, okay, which could be relatively large depending on what you've got. And you might not want to allocate that much capacity. So there's a third option, which is instead of putting it on top of virtual machines, we put them on top of libvirt LXC instances. And you actually nest them. In fact, this is how Karina works. And this is how Karina is able to offer you small units of capacity, right, with bare metal performance. Because we've actually got containers within other containers, and we're composing the equivalent of bays of those containers, like clusters of them.
So
The reason this sounds insane when I say it the first time is because we're all conditioned that virtualization inside of virtualization produces really bad performance outcomes, so we're immediately allergic to that idea. We don't do nested virtualization because performance sucks when you do that. Containers are different. When you run a container, you're creating a C group and a namespace within the Linux kernel. The overhead of that is only incurred at the time that you start a process and that you end a process within that context. When a process is running within a container and it is interacting with the Linux syscall interface, it is having exactly the same performance experience that it would if you were in the root namespace. Okay, so when you nest them, you are not incurring a performance penalty like you would in virtualization, where you're actually taking what our hardware calls treating them through software, right, virtualizing the hardware, and then doing that again. And potentially again, that would be really bad from a performance perspective, right? In containers, the syscall is going directly through multiple namespaces, but is not incurring a performance penalty at all.
but at the end of the day, if it is a process, what do you call nested processes, at the end of the day, if something breaks in between, then you are all. Oh, it's not processes.
No, the processes are not nested. The namespaces are.
When it's set, when it's to you, that's what it looks like. But it flattens out. It's run, right?
So, but security-wise also there is no problem.
Security-wise, look, okay, here's the true security story. Anyone who tells you that containers are as secure as virtual machines is lying. Bottom line, they are not. And there's a reason for that. It's because when you have multiple virtual machines that are running on the same host through a hypervisor, they're going through a hardware virtualization interface. That interface is relatively simple. It is a relatively small number of operations that are simple in nature. When you have containers that are side by side on a host, they need to go through the Linux syscall interface, which by comparison is much more complex. 480 different system calls that are, by comparison, more elaborate than the hardware interface. So that means unless you know what you're doing to secure and reduce that attack surface, then you're taking a higher risk because the attack surface is wider. It's more code, there's more chance for bugs. The probability of an escape from one into another is higher, unless you have a way of reducing that syscall attack surface to such an extent that it is comparable to the risk of what you would do between virtual machines with a hypervisor. It just so happens the Linux kernel does have a set of features that allows you to limit the attack surface appropriately, but you need to know what you're doing. You need to know what you're doing. So the folks that have built Karina, 3 of which are in this room, or 4 of which are in this room today, can tell you more about how we actually did that by approaching and using all of these various features that are in the Linux kernel to make it more and more secure. But bottom line, by nature, containers are not a security isolation mechanism. If that is your primary objective, you're using the wrong tool. Use virtualization for that and put your containers on top. But if what you're after is better workload consolidation, higher performance, more ease of deployment, if those are your primary objectives, then containers are the right tool for the job. So you decide whether you're going to combine them with virtual machine technology or not. And that's why we want to offer this choice. Does that make sense? I know it was a very long answer to a very short question. But
No, it is a complicated thing.
Yeah.
can fill in on that.
You're welcome.
He kind of covered a lot of the security issues I was, so how about the future? Are you guys looking at maybe having some sort of security policy involved with Magnum, or?
No, security policy is currently out of scope. Well,
And what
I mean,
what
access
future things are you guys?
access control, like role-based access control for what you can do in the API is in scope, but security access, security for like host level security for the COE is not currently in scope. It would be great if there was a project that were brave enough to take that on as their primary objective.
Have you thought about things like possibly types of denial of service, like running people from spinning up COEs? And shipping them?
Yeah, so we have the concept of quotas, which is currently being overlaid, just in the same way that any OpenStack service has the concept of quotas, which give you the ability to control the rate and number of a resource that you can create. So that's one way, if you're trying to manage against a denial of service attack, I might say, well, you're only allowed to create 3 bays. And those 3 bays can only have node count of maximum of something, right?
You don't have a good enforcement mechanism.
For quotas, for that,
Yeah.
that's already built into OpenStack.
Sorry.
Yeah, that would just be tapping directly into what's already there. Yeah.
All right.
Yeah, thanks.
I just want to answer the question, one of the answers I would say. There is also an alternative to Docker containers to use Rocket containers, which kind of have already built in security. So the question to you, will you guys support Rocket as an API? Is there any plans for that?
There were conversations between CoreOS and myself in Vancouver at that time frame, and there was an interest in doing that. We have CoreOS as one of the supported Bay node operating systems. So today you can actually choose, by default you're going to get Fedora Atomic as the host level operating system. There's also code in Magnum that supports using CoreOS for that as well. But in terms of using Rocket as the execution engine, the way that you're probably going to get that is by having a flavor of Kubernetes Bay. Because CoreOS's point of view on offering containers as a service is a Kubernetes-centric point of view. So that would be an alternate Bay type that would be Kubernetes that uses Rocket under the covers instead of Docker. So we're open to that if somebody wants to contribute it, yeah.
Yeah, since there are so many Guardian experts, Linux kernel experts in the room, I decided to ask this question. But something I don't understand actually, it's not a question. Docker takes advantage of the union now to add more read-only file systems into the root file system. Can you explain what?
How does file system layering work in Docker?
Yeah.
It's a little beyond the scope of Magnum, but I can give you.
Back here.
Sure. Essentially, how this works is when you create a container, you indicate, and this is a Docker-centric answer. Okay. When you create a container, you specify when you build a container image, you specify what parent image it is derived from. For example, let's say I want to make a container image that's based on Ubuntu.
Would there have to be an operating system?
No, it's not an operating system. It is something that is smaller than an operating system. One thing you got to keep in mind in a Docker environment, you've got one kernel on the host, and you've got any number of containers, all of which will share exactly the same kernel, but all of them can be a different operating system distro. So I can have one kernel, say it's an Ubuntu kernel for sake of discussion, okay? I can have CentOS, and I can have Debian, and I can have all the different Linux distros, Arch, all of them, all running simultaneously in isolated environments, all sharing the same Ubuntu kernel. And when I say this, most people go, what are you talking about? This is craziness. It's not that crazy if you realize that the Linux kernel is the Linux kernel, and the syscall interface is the syscall interface, and actually does not diverge between Linux distributions. It's the same thing. So that's why this is possible, right?
The base image.
So the base image is the thing that you base.
Operating system.
Right. So when you create a container image, a Docker image, you're basing it on one of these base images, one of these environments. Okay, so let's say I select the Ubuntu one. I add my files to it.
So you don't have the same Ubuntu as the within the container as the underlying Ubuntu.
Yeah, the container image contains essentially a set of files that get put onto a file system, but that file system is layered in a mode that is very similar to copy on write. You know the concept of copy on write? Like a copy on write snapshot, right? So say I've got a file, say I've got a block store, and it's got a certain arrangement of blocks, and I take a snapshot of that, and then I modify it. What gets written to the disk? It's not an entire copy of what I had before. It's only the blocks that have changed, right? So I'm only going to create a copy of the blocks that I'm changing, and I'm not copying any of the data that hasn't changed, right? The same concept exists within the container image. It is layered in the same way. So
you delete the original container.
You can't. If it has a ref count bigger than 0, then you can't delete it.
Okay.
You could force delete it, and then everything would break.
Well, yeah.
That's what would happen.
Yeah, it's just that none of the documentation I read ever said that you can't delete it, but it made sense that.
No, if you try to, no, in a Docker scenario, if you try to delete the parent image, if you say Docker RMI Ubuntu, when you have a container that's using Ubuntu as its parent image, well, that will error.
So then would you have 2 containers?
No, you have 2 images, 2 layers, right? We have actually more than that.
But actually only 1 container.
You have 1 running container, yes, and it has 2 dependent images.
Okay.
Yes.
Thanks, Al. We will take the one last question, but I also, no, you're fine. Thank you, Al. You're fine. Go ahead, sit down. You're fine. One last question, and then because I have to let Adrian eat, because I realized I got him all this food and I haven't even let him eat. And we'll be around for a little while afterwards if you want to ask more questions. Also, please clean up your area after yourselves. You'll see the recycling bin and garbage cans over there. I know you would think I'd have to say this, but apparently every time I have to say this because we have a lot of cleanup after people. So please do consider it of the staff here and recycle, and I'm sure you can figure out which things go in which things. And please drive safely, and Sean will wrap it up after the last question. And thanks everyone, and don't forget the meetup on the 25th. Also, you love this topic, so it's on Docker. We have a speaker from Pivotal, Bridget, is going to speak. That's up in San Francisco on the 25th, and also March 10th, more containers and OpenStack in the East Bay. And next Monday, our developer meetup in San Francisco as well. So check the meetup site for those, and please wrap it up with the last question.
Okay, the last question, since you mentioned Farina is using this technology in bare metal, is there any plan to support similar thing on Magnum?
Yes. That was the easiest question of the evening.
Any time frame? When?
Talking about using nested containers. I was having a conversation on the drive over here about that. So I can't give you a specific time frame, but the first thing that you're going to get, the first option besides VMs that you're going to get is bare metal. That's going to come from Ironic. Ironic is in the process of putting that capability in. As soon as that lands upstream, we will make that available as an additional choice. It does work today, except some things don't work. Laugh, laugh, funny, funny. The things that don't work are Ironic's integration with software-defined networks is somewhat incomplete. Its integration with software-defined storage is somewhat incomplete. And there are some caveats that need to be, some gaps that need to be closed there. That is happening, and Magnum is waiting for that to be finished. As soon as that is finished, you're going to get the same behavior from an Ironic instance that you do from a virtual machine instance from our perspective. And as soon as that's true, we're going to be able to give you this dream where you choose your container orchestration engine, you choose the compute type that it runs on top of. Once we have those done, then we're going to give you the third option of nested containers and find some way to explain that to people so that their minds just don't explode every single time we bring it up. But as soon as we can get that where people are comfortable with, yes, what I really want is all of this very tightly packed workloads, where it's containers all the way down, rather than containers on top of entire machines or containers on top of virtual hosts. Absolutely. Since Karina does it, you should probably see that soon. There's also a talk that was submitted. There was a talk that was submitted for the Austin Summit that is proposing this exact concept. So if that talk is selected, I'm on the review board for that, so I'll fight for it. But if that gets selected, that'll be a topic of conversation at the summit, and that will likely accelerate it. Thank you, everyone, for attending.
Thanks, Adrian. So just a small note, don't walk out of the room with a beer bottle, please.